Reconnaissance was and still is the backbone of a country's ability to collect information on other nations. One piece of the reconnaissance pie is the use of satellites orbiting Earth, taking photos to monitor armies, navies, and even nuclear tests. A malfunction in one such satellite would leave a vast portion of northern Canada irradiated in January 1978. Today we're looking at the Kosmos 954 and its crash and subsequent radioactivity release. I'm going to rate it here 5 on my disaster scale. Not great, but also not terrible. The Soviet Rorsat program shows that not just the USA was looking at the feasibility of placing a nuclear reactor in space. The program consisted of 33 reconnaissance satellites, which were used to monitor NATO vessel movements using radar, low orbit altitude. Because of these requirements, a problem was discovered, and that was power consumption. You see, the radar needed power and consistent power, something that solar panels alone couldn't achieve. Not only would shadows of the Earth interrupt operation, but the size of the solar panels would affect orbit. Instead, it was decided to use nuclear power. The USSR wasn't the first to explore nuclear power in space, as the US and NASA got there first with the Snapshot program, although later RTGs were picked over the fully fledged reactors for future missions. For the Rorsat program, a reactor was designed and placed into operation, and this would be called the BES-5 and was a uranium-235 fast fission reactor. The reason for a fast reactor was simply no need for a bulky and heavy moderator. This helps bring the weight down of the entire reactor and radiation shielding to just 385 kilograms, and this included 31 to 44 kilograms of enriched uranium. The reactor had 6 control rods and had beryllium reflectors to reflect neutrons back into the core. The uranium-235 was more than 90% enriched and generated 3 kilowatts of electrical power from a liquid sodium-potassium thermonic conversion of 100 kilowatts of thermal output. After its operation, use of the satellite was designed to shoot the reactor to disposal high Earth orbit to prevent it coming back to Earth, although obviously at least once that didn't happen. It is known that at least 5 satellites experienced failures, with at least one other incident involving radiation release. This brings us to Kosmos 954, and the start of the mission on September 8th, 1977. The satellite sat atop a Cyclone 2 rocket, being launched at 13:55 from the Baikonur Cosmodrome. The satellite orbited Earth around every 90 minutes, but this was changed by December when it began to be erratic, deviating from its original orbit. To be fair to the Soviets, after it was decided that the satellite was uncontrollable, officials contacted their US counterparts, informing them of the situation, including that the now stricken craft couldn't eject its deadly reactor. The satellite, including the reactor, weighed around 4,000 kilograms, all of which were destined to crash somewhere on the planet. Although it was known that the satellite was uncontrollable, it would take several months for it to re-enter the Earth's atmosphere due to the stable orbit it was following. Initial predictions thought that re-entry would happen near to the middle part of 1978, although these predictions would be proven wrong by January. On the 24th of January, the satellite entered Earth's atmosphere while above northeastern Canada. Initially, the Soviets claimed that the satellite must have been burnt up in orbit, but this would ultimately be proved wrong. It was discovered that debris from the satellite had been scattered along a 600-kilometre area between Great Slave and Baker Lakes in Canada's northwestern territories. This happened during a 3-minute burn-up and was observed from telescopic and visual tracking. Searching for the satellite used a joint recovery team of Canadian and US personnel. Some of the radiation detection equipment and aircraft were supplied by the Department of Energy, sent from Nevada. All US units were placed under control, also from the Department of Energy. Immediately after the remains of the satellite had been deposited on the ground, US and Canadian teams scrambled to begin search and recovery operations on the 24th of January. The search area was divided into 8 sections initially, but this would be extended to 14 sections after Area 5 to 8 showed no debris traces. First on the scene was a 22-man Canadian radiation monitoring team. The operation was named Morning Light, and it was given this rather cool, albeit homemade looking logo. A rapid recovery was needed as the radioactive content of the satellite posed a serious hazard to life and the environment. The recovery area posed risks in its own right, mostly in tundra with very little in the way of landmarks, as all, including rivers, was covered under thick snow. 2 C-414s arrived from the US with radiation equipment and personnel. The equipment was attached to Canadian aircraft, with the first being dispatched from Yellowknife on an initial straight line search of over 500 miles. By 4 AM, 4 aircraft equipped with radiation detection equipment had been dispatched. Initially, search areas focused on population centres and main traffic areas. By late January 26th, teams had deployed at Baker Lake and Yellowknife in preparation for the aircraft to indicate where to search. Computer predictions augmented the air search by calculating the satellite's re-entry route. At around 10 PM, a radiation hotspot hinting of a piece of the satellite was discovered by one of the planes just near the Great Slaves Lake, and by the 28th, locals in the areas were notified of the potential hazard in the area. Signs were erected in both English and several indigenous languages. Initially, 2 men from a team of 6 explorers on a 15-month dog sled expedition across the Northern Territories discovered a strange object in the Warden Grove wilderness. When the 2 returned back to camp, they informed their colleagues. Earlier on in the day, the expedition had received a radio transmission about the crashed satellite. The team contacted authorities and a recovery team was dispatched. The piece would be later known as the Antler and had a radiation level of 15 Rontgen per hour. By January the 31st, several pieces of radioactive debris had been located and isolated by ground crews deployed by helicopter. Once on the scene, the search teams made use of handheld radiation detection equipment. Some of the waste was sent to Yellowknife for initial analysis and others were sent to Edmonton. The search effort spanned over 2 phases, between the 24th of January and 20th of April 1978, and the 21st of April to the 15th of October 1978. As time went on, US personnel were phased out of recovery teams. Here are some of the pieces that were found. A metal drum known as the stovepipe found in Sector 1 was a sizable piece, although it wasn't radioactive. 4 steel plate fragments found in Sectors 1, 11 and 12 gave off up to 15 Rontgens per hour upon discovery. Over 40 beryllium pieces giving off between 600 millirontgens an hour to 100 Rontgens per hour on contact in Sectors 10, 11 and 2. There are also several other smaller chunks with the highest giving off 10 to 30 Rontgens per hour on contact found in Sector 10. Although one piece was the hottest fragment discovered, gave off gamma radiation of 500 Rontgens per hour near contact. This amount of radioactivity is more than enough to kill a human if too much time is spent near it. Not only this, but around 4,000 other smaller particles and debris were found during the recovery work. Non- and lower radioactive debris was wrapped in plastic for extraction, and higher emitting items were transported off-site in a special shielded container. It was estimated that the total activity over the entire dispersion area would have been around 2,500 curies. This presented around 20% of the calculated total inventory of the satellite. It is really impressive how swift the recovery of the worst of the debris was, with collaboration between 2 countries. Obviously, the US assistant had an ulterior motive, in the sense of being able to gain intel on the satellite. So, with all the expensive recovery operations completed by 1978, who was going to pay for it? You see, if you launch something into space, you are financially responsible for any damage it might cause when it comes back to Earth. This was called the 1972 Space Liability Convention, so under the terms, the USSR was on the hook for a few dollars. Around 6 million Canadian dollars for expenses was billed to the USSR, but they only paid up around 3 million Canadian dollars. The accident didn't stop the RORSAT program, and the USSR continued to launch these satellite types for another 10 years, finally concluding in 1988.